Welcome to our next lesson where we are going to implement support for updating an existing resource using the put HTTP method. Now, before we dive into the coding aspect of this lesson, I want to spend a moment to discuss the semantic difference between the put and the patch HTTP method. The essential difference between put and patch, even though both of them can be used for updating a resource, is that they have different intent. What I mean by this is that put should be used for a replacement of the resource. When we send a put request to our REST API, we should include the complete representation of the resource, and the representation that we send inside of that request should replace whatever state we have on the server. Now, whether or not this is practical or correct from a business perspective isn't a concern of semantics, which is what we are discussing here. Patch, on the other hand, represents a partial update of the resource, where you are able to specify only a subset of the properties that you want to modify on this resource. The benefit of using patch is saving on network bandwidth because we end up sending more compact requests to our REST API, but the drawback is how it's implemented. We're going to discuss patch specifically in our next lesson, and you will see what I mean by this. And in this lesson, we're going to focus on the pragmatic approach of using put for updates. Now, one more thing that we should consider is whether or not we want to support the upsert operation. Both put and patch can implement the upsert operation, which essentially boils down to inserting a new resource if it doesn't exist, but the downside is that the client has to provide a resource identifier in order for this to work. This means that we're now moving the responsibility of generating a resource ID to the client, which is something I don't like, and it also complicates our implementation of put and patch endpoints, which is why I don't recommend supporting upsert if you don't need it. Now, I will include a good example of supporting upsert in one of the upcoming lessons, but for now, let's jump into the code and see how we can implement updating using the put HTTP method. In the previous lesson, we implemented our post endpoint, which accepts a create habit DTO from the request body, and it creates a new resource on our server. And now that we have our resource, we want to be able to update it. So we can create a put endpoint, and I'm going to decorate this using the HTTP put attribute. Now I will need a route parameter, which is going to represent the identifier of the specific habit or the resource that I want to be updating. And in this example, I'm just going to return an action result response without any content. Let's call this the update habit method. And in this example, we will have arguments coming from multiple sources. First, we will have the identifier of the habit that we want to update, and this will come from the route, which is the ID argument that we specified here. But we also need some sort of DTO in order to specify what we want to update on the resource, and I'm going to call this the update habit DTO. I don't currently have this type. We're going to create it in just a moment, but if you want to make it explicit where this is coming from, you can decorate it with the from body attribute. ASP.NET Core supports multiple model binding sources. If you type from, you can see that you get from form, from header, from key services. So you even have stuff that you can bind from dependency injection. We also have from route and from query. Now, fundamentally, you don't really have to specify this. ASP.NET Core is able to infer where the arguments will come from on its own. So then what should happen inside of our endpoint? Well, the first thing we need to do is to fetch a habit from our database. So I can say database context habits, and we can say something like find async, first or default, single or default. Let's say I go for first or default async, and I want to fetch the habit where the identifier is equal to the ID argument that we get from the route. So this could be null, and in this case, if the habit is null, I want to return 404 not found. If we make it all the way to here, then we have a valid habit that we want to update. Then the next question to ask is, how do we actually apply this update? So one thing you could do is, for example, manually set the updatable properties based on the DTO. And this can become pretty cumbersome. So I suggest defining an explicit extension method. Let's say update from DTO, and we're going to pass in the update habit DTO as the argument. Then I can call database context save changes async to persist my changes in the database, and then I can return something like 200 OK by just calling the OK method, although the more commonly used response for the put HTTP method is no content. This will return the 204 status code and the response body will be empty. Now let's focus on the actual update habit DTO. I'm going to refer to the create habit DTO as the baseline for this implementation, and let me create our type. So this will be a public sealed record, update habit DTO, and then let's just copy all of the types from the create habit DTO into the update habit DTO. I will move the update habit DTO into its own file. We can close down the create habit DTO, and now let's focus on updating our resource. I said that the HTTP put method should effectively be a complete replacement of the resource on our server. In reality, this isn't a really practical way to implement put. For example, some of the properties on the habit entity shouldn't be updatable from the API directly. I don't want the API clients to be able to set the status of a particular habit. I may not want to archive the habit in a put endpoint. Maybe a dedicated endpoint like a patch endpoint would be more appropriate for something like this. And then there are some internal properties like when it was updated and when it was last completed that should be dictated by our backend logic. So even though we are building a REST API and following the RESTful principles, that doesn't mean that we should completely disregard that some of our business logic actually lives on the server. Let me close this down. Now, one more thing I should consider is, for example, how I'm updating the milestone. The milestone DTO has both a target property and a current property. And is this something that I should be updating directly on the habit? I think that the answer is no. So let's create an update milestone DTO, and let's replace the milestone here with our new DTO where I can only update the milestone target, and we're going to omit the current milestone value. So let's say I'm happy with my DTO implementation. It contains all of the properties that I want to be able to update on my habit instance. Now all I need is a method that's going to allow me to map from my DTO into my entity instance. So let's go to the habit mappings and let's define a new extension method. It will be an extension method on the habit type, and I'm going to call it update from DTO, where the argument is going to be our update habit DTO. And then I'm going to drop in the implementation and let's go ahead and review it. Basically what I'm doing is mapping from my DTO properties into my entity instance. We have our basic properties, our complex types like the frequency or target. We have the milestone where we can only update the target and we won't be updating the current property, at least not from the API directly. And I'm also updating the property when the habit was last updated. And with this method in place, my controller endpoint should now be complete and we can test out our implementation. So let me first send a GET request for a habit with this identifier, and you will see that we are getting back a response. So this is the current state of my resource. As you can see, it hasn't been updated in the past, and these are its current values. Now, if I go into my put endpoint, I prepared a request that I'm going to send to my backend, where I changed the description, the target value, and I also added a milestone target. So if I send this request, we will hit the breakpoint inside of our put endpoint, where we are first going to fetch the habit from the database. If it did not exist, we would get back a 404 not found, but because it does, I'm going to proceed into my helper method, which is going to map the name, description, and the other values from my DTO into my entity instance. Now in this example, you can see that the DTO milestone isn't null, while the milestone on the habit is null. So we're going to go ahead and create it. And we're also going to change when the habit was last modified. Let's go ahead and persist this by calling save changes async. And now I can go ahead and return no content. We will go back to Postman and we got our 204 no content response. And now if I go ahead and send another GET request to obtain my habit, you will see that the values have been changed. We now have the milestone present in the response because we have introduced it in our previous put update. The target value is also changed, and so has the description and when the habit was last updated. So our update using put is working as expected, even though it's not a complete replacement of the habit resource. Now let's say I want to send the same put request, except this time I will change the resource identifier into something that probably doesn't exist. If I go ahead and send this request to my backend, I will get back a 404 not found response because a resource with this identifier doesn't exist. So let's do a brief recap of what we implemented in this lesson. We added a put endpoint, which allows us to update a single resource, in this case one habit, inside of our system. We created a dedicated DTO that we bind to from the request body, and we also have an identifier that we get from the route. We try to find this habit in the database. We return 404 not found if it doesn't exist, and if it does exist, we map from our DTO object into our habit entity. We then persist the changes and return 204 no content. And inside of the update method, we define our simple mapping, and this is probably where we could include any business logic that would need to happen in case of an update. If you don't want to maintain this type of logic inside of extension methods, you have a couple of options. First, you could move this method onto the habit entity itself. Make it an instance method, and now your logic is encapsulated with your domain entity. This would be moving towards more of a rich domain model. Another thing you could consider is creating a dedicated class that represents your update use case, where you can encapsulate this business operation. Coming from a clean architecture perspective, I refer to it as a use case, but you could also create something like a service, although I'm not too happy with that naming convention because we end up placing a lot of code inside that would probably be simpler to reason about if they were just simple, focused use cases that deal with one business operation. Another way to think of this is having dedicated vertical slices. Now, we are diving a bit too much into the architecture side, so let's revert back to RESTful APIs. In the next lesson, I will show you what is necessary to implement partially updating your resources using the patch HTTP method. We're going to explore the JSON patch document and how you can use it for performing partial updates.